Hello again. Alright, MCA review kids, we are here to talk about congruent triangles. So, let's get started. Two geometric figures are considered congruent if they have exactly the same size and shape. So, everything's got to be the same. Size, shape, length, everything. Angle measures, everything. So, when two figures are congruent, that means there's a correspondence between their angles and their sides such that corresponding angles are congruent and corresponding sides are congruent. If we remember the word congruent, it really means equal, the same. So, here we go. If we look at these two pictures, these two geometric figures, these triangles, they're actually congruent. So, let's get used to the idea of this congruent and let's state what corresponding sides and angles might be. So, corresponding angles are going to be angle A, and it's going to correspond to angle X. Well, what did we just state about these? These corresponding angles are going to be congruent, meaning equal. Another one, angle B would be congruent to its corresponding side. Notice this is the biggest angle, and so is angle Y, so angle Y. Let's try another one. Angle C would be congruent and corresponding to angle Z. Let's talk about corresponding sides. Segment AB, this side length is corresponding to XY, and therefore they would be congruent. Next one, segment BC is corresponding and congruent to segment YZ. Lastly, segment AC is congruent and corresponding to segment XZ. They are all of the sides and angles that line up. Notice I kept the smallest side with the smallest side, the largest side with the largest side, same with the angles. So we need to watch those things and make sure that they work. Not all of the pictures are going to be this nice. Sometimes things are going to be turned, flipped around, so you need to be watching out for when those triangles are turned or flipped or whatever. Watch out for which one is the biggest angle, which one is the biggest side, which ones correspond, which ones are congruent. All right. There are multiple ways. If you look our list, there's 5 ways to prove that triangles are congruent. And let's talk through those 5 ways. If you are given triangles, you can prove that they are congruent if you know all 3 sides are congruent. If you only know that all 3 sides are congruent, that is enough information to prove that the triangles are congruent. Next, if you have a side angle side situation, you can prove that those triangles are congruent. Let me be specific here. This has to be 2 sides and an included angle. An included angle means between. So the 2 sides that we're talking about, the angle has to be the one that's created from those sides. It's got to be included. Now, if you know that a side, an included angle, and a side are congruent to another triangle's side, angle, and side, even though that one's flipped around, maybe a little small. But if you know that those things are congruent, you can prove that the triangles are congruent. Let's try the next one. Angle, side, angle. Again, the idea that the side is written in the middle means it needs to be an included side, meaning it has to be between the 2 angles that we're talking about. So if we have a triangle that has an angle and a side and another angle, we need to make sure in that other figure we have the same information, that it's the included side. Notice it's the side that touches both angles, included. So if angle, side, angle is the same on both triangles, then that means those triangles are congruent. Another one, angle, angle, side. So you have 2 angles and a side, meaning it is not included. Then those triangles are also congruent. That one works as well. Last one is the hypotenuse-leg congruence theorem. It says if the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of a second triangle, then the 2 triangles are congruent. So right triangles, and right triangles only, have this special property that if the hypotenuse and one of the legs are congruent in the 2 triangles, then the triangles themselves are congruent. So what we're going to do is try to use these 5 ideas to show when triangles are congruent. So here we go. It says, decide whether it's possible to prove that the triangles are congruent. If it is, tell which congruent postulate or theorem you would use. So let's look at this first picture. We are given that this side is congruent to this side. And we are given that this side is congruent to this side. So we have two sides so far. And just those two sides are not enough information. But what we've also been shown are these triangles. What these triangles mean are that these lines are parallel. And if you remember anything about those parallel lines cut by a transversal, is that corresponding angles are congruent. So maybe it wasn't marked on the picture that they were congruent, but I can prove that they are congruent because of those parallel lines. So if we notice, we do have enough information to say that these triangles are congruent, and how we know that is because of the side, angle, side. Side, angle, side. Congruence theorem. Okay, let's try the next one. Do we have enough information to prove that these triangles are congruent? Well, let's take a look. I have one side, but I also have a right angle. And notice this one would also be a right angle because they're supplementary. They have to add up to 180 degrees. And also, do you see that they share a side? So what I actually have is two right triangles sitting right by each other, and I know that the hypotenuse, the side across from the right angle, and one of the sides is congruent to the hypotenuse and side of another right triangle. So this is actually the hypotenuse-leg theorem. Because we have right triangles and the hypotenuse and the leg were congruent in each of the triangles, I know that those two triangles are congruent. All right, let's take a look at number 3. In number 3, we are given an angle, a side, and another side. Now, is the angle included? No, it is not between both those sides. So this is a side-side angle, which is a big old no-no. Do not do that. That does not prove congruence ever. It does not work. We do not know that these triangles are congruent. We do not have enough information. So these are not congruent because we do not have enough information. So let's keep that in mind. Just because they may look like they're congruent doesn't mean that they are. We have to be able to prove it. Moving on, next one. I know these sides are congruent. These sides are congruent. And I also know they share a side. So what I actually have here is the side, side, side case. These triangles are congruent because all three sides are congruent. So that is a side, side, side congruence. Okay, number 5. Let's see what we got here. I have one side, but I also have this whole parallel idea. And if you remember from our studies with lines and angle relationships, the angles I just marked are called vertical angles. And vertical angles are always congruent. Also, let's look at these parallel lines cut by a transversal. These would be alternate interior angles. And I know alternate interior angles are congruent on parallel lines. So, do I have enough information to prove that these are congruent? The answer is yes. How do I know that? In this case, I have angle, side, angle. So I have enough information. Okay, let's check the next one. Again, we have this whole parallel lines idea. So we look at the transversal. Alternate interior angles are congruent. Okay, let's try this. Let's look at these parallel lines and consider this the transversal. Well, these are also alternate interior angles, so those ones are congruent as well. Great, okay, making a little bit of progress here. Let me just rewrite this all in. We proved these were alternate interior, and these were alternate interior, and vertical angle shows me that this one is congruent to this one. So I know that all three angles in both triangles are congruent. Is that enough to prove that the triangles are congruent? No, we did not have an angle, angle, angle written down. That does not prove congruence. Actually, it proves similarity, not congruence. So, are these triangles congruent? They are not congruent because that is not a property of congruent triangles. We have to have more information. We have to know something about a side length, and we don't in that case, so we cannot prove that they are congruent. Okay, so this one says the same thing. Decide whether it is possible to prove that the triangles are congruent. If it is possible, tell which congruence postulate or theorem you would use. I encourage you to pause the video at this time and try doing these 3 questions on your own. you did pause the video, hopefully you have the answers. If you didn't pause the video, well, I'll just continue on through and we'll see what we got for an answer. In this case, hopefully you found that. Yes, they are congruent because of the side, side, side congruence theorem. Next one, again, they are congruent because you needed to realize that vertical angles were congruent, and therefore we were given side, angle, side. Side, angle, side. Therefore those triangles are congruent. And the next one, notice these angles are congruent. These angles are congruent and they share a side. So these ones are actually also congruent triangles, and that's because of the angle, angle, side congruence theorem. Okay, so hopefully you guys did well on that. One last set of problems. And this is for you to state the third congruence that must be given to prove that the triangles are congruent. But here's the tricky part. You have to prove that they're congruent by the indicated postulate or theorem. So we have to use what they're telling us. So if we look at the first one, they want us to prove that they are congruent by angle, side, angle. So I need to make sure that that side is included. So if we look here, we have an angle and a side. We need another angle. We have to choose the appropriate angle that would make the side included. Angle A is not going to get that done. C is going to get that done. And in this picture, it would be angle F. So stating that third congruence, we would need to prove that angle C is congruent to angle F in order to prove that these triangles are congruent by the angle, side, angle congruence postulate. All right, let's try the next one. This one wants the angle, angle, side congruence theorem, meaning the side is not included this time. It's not in the middle. It's left out on its own. So this time, we don't want to include the side. We want it to be left out. So we want to come down here so we have an angle, angle, and a side not included. Same with this picture. And it just so happens with the way they're labeled that, again, we would need to prove angle C is congruent to angle F. Okay, two more. How would we prove that these triangles are congruent using side, side, side? Well, that means we need to have all three sides being congruent. And this time we are only given two of the three sides. We would need to prove this side and this side are congruent. And if we notice, if we write this down, CB would have to be congruent to, I'm going to be picky about the way it's written here, we're going to have to be congruent to FE. Notice I went from the 1 to the 3. Okay. Keep that same order. All right, let's try the next one. Side, angle, side. Notice the angle is in the middle, which means that angle has to be included, meaning touching both of those sides. So the only angle that touches both given sides is angle A in this picture and angle D in this picture. So I'd have to prove angle A is congruent to angle D in order to prove that these triangles are congruent by the side, angle, side congruence theorem. So that's all I have on congruent triangles. Things to remember, how to prove congruence. You have a couple of different options. You have side, side, side. Side, angle, side. Angle, side, angle. Angle, angle, side. And the hypotenuse leg theorem. Keep those 5 things in mind. That's how you would prove triangles are congruent. And good luck.